Question number 11 says the following. An emergency flare is fired from a boat at B. Okay, so there's B here. An emergency flare is fired from a boat at B on a lake. And then it says the surface of the lake is shown as a horizontal dashed line. This is the lake, the surface. The flare comes from here, it goes up, going wherever. And then it says here, the flare's journey can be modeled by this equation. Clearly, this equation is an equation of an exponential graph. And then it says here where h is the height of the flare from the bottom of the lake in meters, and t is the time taken in seconds. So just keep in mind, this is just an exponential graph. So because this is a 10, which is going to be representing the asymptote of the exponential graph, it means here this is just a 10. And I mean, this would just represent an x-axis, this would just represent a y-axis. Just look at it exactly like that. So just because I'm using a real life scenario does not mean that your way of thinking when it comes to Cartesian planes changes. It does not. So here it says, what depth is the lake? So remember they said this is the surface of the lake, right? And then they said that h is the height of the flare from the bottom of the lake in meters. So they said here the flare is fired from B on a lake. The surface of the lake is shown as a horizontal dashed line. So this is the surface of the lake, and you see at the bottom there is just down there where 0 would be. So when you ask for the depth, it's just 10 meters. You see, there we go. How high above the lake surface was the flare fired? So you want to figure out the y value of B. The y value of B, remember, this is just an equation. This is just a what you call an equation, right? So if you want to find out the y value of B, you already know that here at B, the value at B here, the value for T, right, is a 0. So you're just going to throw a 0 in this equation, you see. So throwing a 0 in your equation there, you have 2 to the power of 0 plus 10. Anything to the power of 0 is a 1. And then you have a 11. So here you can say, therefore, at 11 meters above the, wait, if it's 11, this is 11 meters from the bottom. So if it's 11 meters from the bottom, it is only 1 meter from the surface, you see? At 1 meter from the surface. This is why these kinds of questions, you just have to be careful, because our equation gives us the height from the bottom. So if our height here from the bottom is an 11, it means from the surface itself, it's just 1, which is what they're asking. How high above the lake surface was the flare fired? It was just fired 1 meter above the lake surface. So let's keep things moving. It says here, after 5 seconds, the flare has ascended to height E. There you go, height E. And then they said, how high is this from the bottom of the lake? Well, the fortunate thing is they told us that it's after 5 seconds. So it's just a matter of putting 5 in the equation of H. The equation of H, we're going to throw a 5 there. 2 to the power of 5 is 32. This is giving us 42. Nothing crazy there. So this is also giving you the idea that you have to keep a calm head when you go through these kinds of questions. Keep a calm head. Here it says, how long after it is fired is it 8 meters above the lake? So 8 meters above the lake, you have to be careful now. It's not 8 meters above the bottom of the lake. This is referring to the surface. You see, surface. Because if you look at the question, the way it's talking, right? They're saying here, how long after it is fired is it 8 meters above the lake? So you have to consider that if it is 8 meters above the lake, this would be 8, right? So our equation, we have to be careful to make use of 18, you see, because our equation only takes into account a distance from the bottom of the sea. So if you want to find out the time, right, where it is 8 meters above the lake, you have to put a distance of 18 in your formula, because your formula here for h, it takes the distance from the bottom. So you know that if this is 8, the distance from the bottom will be 18. So that's what you need to put there, and then you need to solve for t. You see, solving for t here, you're going to say 18. Let's go to 2 to the power of t plus 10. And just write this a bit better. Power of t plus 10. This is a t here. 18 here. Now, the formula, remember, is h with t here, 2 to the power of t plus 10. Now here you can take the 10 to the left, you minus, so it's going to be 18 minus 10, which is 8. And we already know that the only thing that can give you an 8 is if you have a 3 as that exponent. So here, therefore, t is equal to 3. Wow, would you believe that? This test literally just ended out of nowhere. But you can see that your nature of your maths exams, right, it doesn't change. You have algebra, sequences and series, financial maths, probability, and then you have functions and graphs. In this case, we almost had a hint of applications of functions and graphs, which we know in grade 12 boils down to applications of calculus. So the big idea, as you can see with this paper and why I went through it, is I wanted to give you a wake-up call to say, don't leave your basics behind. Don't take it for granted that this is a grade 10 paper. Don't take it for granted that if you're in grade 12 and some of these questions were difficult, it means you really do need to do what you can to do better, you know? So that's why I always recommend the online courses on our website, because the online courses on our website, they're going to help you patch some of these gaps, you see, which is why I, for example, mentioned something like the algebra course is something that even a grade 10 learner can do, because that grade 10 learner needs to be able to answer questions like this. You see, they need to be able to answer questions like what we have here in section B. And we all know what section B looks like. You see, things like this, you need to be able to answer that. Things like this, you need to be able to think on your toes. You see, things like this, you need to be able to think on your toes. So I highly recommend that you sign up for the online courses on the website, depending on when you're watching this, right? Obviously, the online course main package, which is the all access pass, which gives you access to everything, it is currently on sale, right? The all access pass, there we go. You see, it gives you access to 17 courses all at the same time. It is currently on sale until the 7th of November, you see, and it's just going for 99 Rand. If you make a purchase, you get access to everything. The everything that you get access to is, you see, Euclidean geometry, functions and graphs, trigonometry, and it's basically the entire syllabus, and it includes the NBT course, see. So you definitely want to take advantage of all this while it is still at your disposal. From my side, that is all that. You can see here, I was going through this paper because this is a paper that one of the students that I tutor privately is given. They got this paper as like a practice paper. So obviously, in terms of the sessions that we have, right? The deal was I go through the full paper. He also goes through the full paper. And then during our next session, he will at least have the link to this, and he'll be able to like go through the different questions that are a bit tough. And then obviously when we do meet, he'll be able to like pinpoint out anything that we may have to just touch up on again. You get it? So that's the big idea behind why this paper is here. There will be more papers like this going forward, because I do think that whether in grade 10, 11, or 12, these papers are actually quite helpful. From my side, I will catch you in the next video.